about multiplexers. It is also called as MUX in the short form. What is a multiplexer? Generally, a multiplexer places data at one of its 2 to the power of n input lines. So, input here is 2 to the power of n by an n bit address. So, this is the n bit address here and its output line. The number of output will always be 1 here. So, what we have to underline is regardless of the number of inputs, the output always will be 1. So, there are different examples of multiplexers like 2 to 1, 4 is to 1, 8 to 1, 16 to 1 and so on. So, in this topic class, let us understand about 4 is to 1 MUX. Let us draw the diagram for 4 is to 1 MUX. So, it has only one output. Let us represent that as F. Then A1 and A0 as the enable lines. Then D0, D1, D2, D3 along with enable is E. So, this is the symbol of 4 is to 1 MUX. Let us understand truth table and functional table for 4 is to 1 MUX. So, it has enable A and the two lines A1 and A0, then the inputs D0, D1, D2, D3 along with the output F. So, whenever the enable is 1, regardless of the inputs, the output will be 0. That's why we are representing this as X. That means whatever may be the input, if enable line is 1 in your MUX, the output always will be 0. Next, let us imagine 0 and 0. So, A0 is 0, A1 is 0, 0 and 0. Here, it is regardless of D0 will be 0 and 1 and others all will be AX. F and F is 0 and 1. Similarly, if E is 0, 0 and A1 is 0, 1. So, you can see the pattern here. This is your 0, this is your 1. Now, other than 1, all other will be X. So, 1 it will become 0 and 1. Then remaining will be XX. So here again you are going to get the output as 0 and 1. Similarly, in the next line, we'll assume 1 0 1 0 and 1 1. 1 0 here X 0 X, then X 1 X, the output will be 0 and 1, and the final column also the output will be 0 and 1. Now, how to write the functional table? The same E, A1, A0. Let us simplify this. Whenever it was 1, F was regardless of not. So, whenever it was E1 was 0, now in the first case, when we took 0 and 0, we got D0 value only. That is your 0 and 1. Next, when we took 0, 1, you got D1, then you got 0, 1, 0, it is your D2, then 0, you will get D3. Now, when you solve this expression, you will get D0 into A1 bar, A0 bar, D1 into A1 bar, A0, D2 into A1, A0 bar, D3 into A1 and A0 along with enable E bar. Now, if you need to implement, so we require 4 inputs D0, D1, D2, D3 along with A1, A0 and E as the sublines and F will be your output. So, we also have an IC by the number 74153. We call this as dual 4 is to 1 MUX. Dual 4 to 1 MUX. So dual 4 to 1 MUX. What do you mean by dual 4 to 1 MUX? It has two 4 is to 1, 4 is to 1, 4 is to 1, 4 is to 1 with the output F1 and F2. So what it has? It has a enable, then 4 input lines. It has enable and 4 input lines. So hope you understood about multiplexers. Thank you.